Hello guys, I welcome you to the channel which is Introduction to Aerospace Engineering regarding videos, regarding using different media, and we have covered so far 21 videos regarding engineering, aerospace engineering, flight dynamics, numerical and theoretical parts with different concepts and different explanations. And we are actually covering these topics with the help of different textbooks, and if you are interested we can mention the textbooks as well. But the purpose of this equation or this video is to provide you just an explanation of the equations of motion regarding airplane. And when we talk about the equations of motion, we talk about the forces of flight, and we talk about how we're going to represent the forces of flight in deriving the equations of motions for airplane. So that is why I have actually chosen this topic, which is in the course books of the aerospace engineering, and we're going to cover it with the help of obviously the theoretical and the pictorial representation, and we'll try to actually summarize it so that we can say that we have covered a lot of the topics which may actually help us to form the basis of the applications related to the aerospace or the aerodynamics. So let's see what we have in terms of theory, in terms of explanation, or in terms of notes that we have actually just chalked it out for you guys. And if you are interested to have some clear view, you can just mention it out. I hope that the view is clear. The equations of motion, four forces of flight: lift, drag, weight, and thrust. And direction of a stream velocity, which is v of infinity, is always in the direction of local flight of the airplane. Okay, it is always in the direction of the local flight of the airplane, and the flight path is horizontal. Okay, this is horizontal flight path, and hence free air velocity is also horizontal. You can see that is also horizontal, but obviously in the opposite direction, that of the thrust. This is lift, this is weight, this is drag, and the airplane is in front of you. So equations of motion, this is the Earth's surface, and it is the climbing flight. The flight is now in the curved position, the curved flight path, okay, which is obviously mu is also the angle from that parallel side, and thrust is also applied, and this E is applied at this point. And we have E as well, which is parallel in the direction of the flight, horizontal direction of the flight, okay, which is the angle. And normally this is parallel, but over here this angle has been created by the curved path, and you can see that is lift, and this is weight, this is drag, and this is thrust in front of you. And also when we see it more clearly, we can have the side view as well. We can have also these two are the same view. I mean, it is taken as a curved view or horizontal direction, but we talk about the side view and also of the front view or the sectional view. We just have this, because in this part obviously the components will be differently oriented, but it is on the plane. The plane of the page is in the same actually direction as that of these horizontal flight path. But in this, which is the side view, when we have some angle, which is normally this mu, and also we have the velocity when airplane is rolled forward, that is with which banked. Roll mean banked with some angle. When airplane is banked or rolled with some angle in the forward, the viewer through angle F, which is through this angle F. Okay, so we get not the direction, or we not have the horizontal plane. We do have just a different plane as per different from the page, okay, which is in front of you. That is why when we have the rolling effect, we're just going to talk in detail later on, but first of all just discuss about this part. When we have the plane in the horizontal direction of the flight, and let's see what we can actually explain in terms of theory, in terms of equations of motions for an airplane are simple statements of Newton's second law, because these equations are derived from the Newton's second law, which is F is equal to m of a. Okay, so this f of a M of A is what? Vector equation, and vector equation in x-axis is Fx is equal to max. Component of force parallel to flight path is this. Now this is component of force which is parallel to this. F force is now, which he has explained like this, that it would be, just explaining it in this form. This is the component of force parallel to flight. This is T cos of E, which is obviously the angle, minus D, which is drag, and that also would be minus, would be this weight factor, which will be W of sine of theta. So that is how you're going to derive an equation of a vector equation which will be parallel to flight path. Okay, so this is how you're going to derive it. But obviously keep in mind we have a curved path and we have a curved path, we have the airstream velocity in the opposite direction. We're going to derive the instantaneous velocity as well. We're going to derive the instantaneous acceleration, and let's see how we can actually go further with the help of these. This is what, with the help of this we get the component of force which would be parallel to flight path is T cos of E minus T minus W sine of theta. Now acceleration parallel to flight path would be what? Obviously change in velocity with time is acceleration, so then we have to have d derivative of velocity over time, that would be acceleration parallel to the flight path. Okay, because we have taken the force, we have taken the acceleration, and now we're going to apply the second law of motion, which is F is equal to ma. Now m would become what? dv, a derivative of velocity with time, and v is equal to component of force, that would be this one, T cos of E minus D minus W sine of theta. So here is in front of you this one. Okay, this equation has been driven. And when we're talking about the perpendicular direction, we have talked about parallel. In the direction perpendicular to flight path, the component of force would be, parallel or the perpendicular to this would be how? This is L cos of theta. Okay, and then we're going to add this one, which is also this, at T or sine of E or cos of theta, this one, adding this one L cos of theta minus this, which will be the downward direction of the weight, that would be minus W cos of theta. So how you're going to add these two? You're going to subtract this one. You're going to have the component of force perpendicular to the flight. This is how you're going to do it. Okay, so this is how it has been explained. Radial acceleration of curvilinear motion perpendicular to flight path is this. Now we have the acceleration as well, which is this one. And we're going to have the change in this one, because of the radial acceleration of curvilinear motion perpendicular to flight path is this. You have the local radius of curvature, which is r1. Now we're going to have what you can say the centripetal acceleration, and that needs to be explained by this v, air velocity, which is v squared divided by r of 1. That acceleration is because of the perpendicular component of force. Keep in mind, we have the propeller, this one was just because of the parallel component. You just have to take the derivative, but in case of acceleration it would be the radial acceleration, and radial acceleration is normally because of the centrifugal force, and normally it will act like it will because of this. Okay, where v of square over r of r1. Okay, and radial acceleration of curvilinear motion perpendicular to flight path is what? Is of flight path in the plane of what? In the plane of the plane, not exactly. So hence Newton's second law to taken perpendicular to flight path is this, ma perpendicular, which is equal to force perpendicular. When we're going to apply this to mv square over r1, we have L cos of theta plus T sine of E cos of theta minus W cos of theta. So this is how you're going to have this equation as far as the perpendicular component of the force is concerned when we have this part. So this is how we're going to explain it. And further talking down the road, let's see, it is force is this one, L sine of theta into T sine of E into sine of theta. A2 is V cos of theta squared into R2. This one is equal. Also, we have driven the equation in terms of theta as well. So this is how you're going to have the explanation, and this is how you have the explanation when we're talking about the instantaneous components. When you're talking about the instantaneous force, we're talking about the instantaneous acceleration, so you can have this one as well. Okay, so this is the whole explanation of the parts. This is whole explanation of the equations. We have derived the equations, we have derived the path as well, we have derived horizontal forces, component of force, perpendicular component of force. These are all the equations of motions of airplane relative to what? The Newton's second law of motion. Okay, we can explain F is equal to ma in terms of vector form as well, in terms of scalar form as well. But in terms of scalar form, obviously there is non-dimension. In vector form, there will be a direction normally, which is the pertinent part, and F is equal to F in vector form is equal to m into a into vector form as well. So this is how you're going to explain normally, and this is we have, instead of actually taking the whole aeroplane, we have taken just the point A, and we have actually placed on the components of force relative to the force, the drag, thrust and weight at this point. So that means that is the instantaneous flight path. So we can have the instantaneous components as well. We have the instantaneous component of velocity and all of that stuff. So that is how you're going to explain it. I hope that is enough for you to actually get an idea that what are the different components and what are the different components of forces relative to these equations of motions and relatively like Newton's second law when you're talking about the airplane flight, and when we're talking about the lift, drag, weight and thrust. Okay, so if you have any questions regarding this, because I have explained this, if let me have, because of this one, that when it roll over, okay, just having this section, when it is roll over, it would be creating this one factor. We're talking about this, that would be head on, okay, W cos of theta, which is a head on front view. Okay, you just have to keep in mind that is L, which is the eagle view of the vertical plane. Okay, and that would be also eagle view of plane symmetry. Okay, so T sine of E, this F is also the component we're talking about when it is not, the plate is not in the direction of the page plane. It is just actually pointing, just giving us the front view. So that is how you're going to have the path, and you're going to have the eagle view of the vertical plane and eagle view of the plane symmetry. Okay, that is how, because this is, in this case it is, we say that the plane is in symmetry with the direction of the flight and also with the page plane, but in this case obviously it is symmetry in the when we're talking about from the front side. Okay, so that is the only difference. And we can also have, let me actually give you an example if I have actually explained, yes, this one, forces projected into horizontal plane parallel to flat earth surface. Okay, and this view, in this case there was earth surface and there was a climbing flight. But when we talk about the component of the forces, when we're talking about the forces projected into horizontal plane parallel to flat earth surface, so this is how, when we have this flat projection of flight path, this one. Okay, and this is also the center of gravity for airplane, this one, center of gravity for the airplane. And we have discussed about T cos of E, T sine of E, cos of theta, this, and adding this one to L sine of theta. When you have add this one, you're going to subtract this one, you're going to subtract this one. Let's see if we have any sort of the equation for this one. Okay, the force component would be what? this and this adding for this view, okay, L sine theta and this, and when we have the acceleration would be this one, okay, and that would be the velocity change in the velocity producing the acceleration, and v cos of u whole square, and that would be divided into r of 2, okay. So that will whole effect will give us ma is equal to this force component of force. This is this would be the equation derived when we have the forces parallel to the horizontal plane or to the flat earth surface. This is how it has been taken, this is how it has been explained. So I hope that the effects you are just taking relative to the what, relative to the surface, flat earth surface, and you are taking relative to a point as well. You are taking some of the projections, you are just taking the center of gravity, and that's it. And you are explained with the help of the vertical and also the downward component as well, whether it is actually in the upward or whether it is downward, just taking the projection of the flight path, okay. So this is more or less the explanation that I hope that I've actually explained with the help of the forces of equations of motion when we're talking about the Newton's second law of motion, symmetry to the page or asymmetry to the page plane, and also we have discussed about relative to the surface, Earth's flat surface, and we have actually taken the 3D, the three-dimensional components, and we have also discussed the three-dimension in space. And when we have discussed the three-dimension in space, that would be normally Fs, which is equal to m into a of s. That would be the second Newton's second equation of motion when we're talking about the space. When we're talking about the vector form, that would be F is equal to ma. Talking about vector form, we have actually talked about the point as well instead of the airplane, and because of that point we can actually explain the sum of the components relative parallel to the velocity, and also we have the weight component, we have the lift component and the drag component that also adds on to the all components of forces, and we have a very sound explanation of all the four component of forces when we have it in a symmetric or asymmetric to the plane of page. So you can have the explanation as well by yourself. I hope that I have explained enough. If you have any other questions, you can let me know, and we can actually work on those lines just to clarify, so that obviously there is no ambiguity, there is no confusion whatsoever, and I can move in a very actually professional and also in a more you can say studious approach, just keeping the concepts and the application of those concepts side by side, and also actually covering in terms of different course books, in terms of different actually material. Obviously the main would be the IIT institutes, and obviously all these course books and syllabus and all the journals and all the questions, and if there are actually any journal explanation, or if there is any material in terms of journal, we help to actually provide that material actually written by any authored by any actually you can say researcher, giving us the point of his or her thesis, so we can actually share that point of view as well if it is actually in the in our domain of work, especially when we're talking about the engineering, and we can share different journals published on a regular basis, approved by the societies, approved by the international community, so that we can have an insight about the work, about the research of those students, of those researchers, or even at the postgraduate or even at the postdoc level. If anyone is doing the research work at that level as well, we're going to definitely share the work and the experience in terms of our language. We'll try to explain it, obviously keeping all the copyrights intact, and also giving the healthy contribution towards the channel, so that we can expect and reciprocate the same from the viewers, from the public in large, and they can actually help us actually complete or even eventually have the sound concepts more and more sound as well. This is the whole purpose of actually giving out these videos, so that we can share the conceptual framework of different students and different researchers, and even from the different professors or the teachers at different levels, so that we can combine their work and produce them in terms of videos and share them for the public use as well. Just normally when you actually go and visit any book or any library, instead of that you can have on the YouTube, and you can actually have all the details actually just at a click. We will be hoping to have you as a platform user. If you're going to watch it anytime, we'll be constantly in touch with you. I'm going to be actually just touching other concepts of the aerospace engineering, and obviously we're going to share it, all the different concepts linked with one another eventually, but just want to have the different approaches at different times, just for robust and a holistic approach towards understanding the aerospace engineering. So hope to see you with another interesting video. Till then, take care and have a nice day.